A neural network is a data processing model used in artificial intelligence inspired by the way our brains function. With neural networks, we can, given a set of inputs, identify, classify, or make predictions about items based on their properties. Neural networks build on the concept of logistic regression that you've already seen in Section 4 to allow for non-binary classification and to more closely fit data. So how does a neural network work? A neural network is made up of units called neurons. Each neuron takes a set of input values, applies individual weightings to those values, combines them, and adjusts this combined value to produce an output value. If two neurons have different weightings for the same set of inputs, those neurons will generate two different outputs, effectively different interpretations of that input data. By adjusting these weightings, you can configure the neurons to produce specific outputs for specific inputs. This is the key to how neural networks function. You can arrange these neurons into layers and connect each neuron's output in one layer to become the input for each neuron in the next layer. In doing so, you can set up your network to handle very complex problems across large input sets simply by adjusting every input weighting for each neuron. Let's take a look at the iris data that we saw in Section 4. There are 4 input parameters: petal length, petal width, sepal length, and sepal width. If you built a neural network for the iris data, it could look like this. In this case, this network has been set up to classify the input data based on the petal size. The input weightings on the hidden neuron H3 allow it to respond to small petals, while H4 responds to large petals. The output layer uses the results from these to classify the flowers, so flowers with small petals will be classified as setosis, while flowers with medium-large and large petals will be classified as versicolor and virginicas respectively. This is all well and good, but configuring the weightings for the network by hand is no easy task, especially on a large network. Thankfully, we don't have to. Neural networks can be trained, one of the reasons they're so popular. To do this, we can start all the weightings for all neurons off as random values. This will ensure that each neuron responds differently to the inputs. We can then provide a set of inputs for which the desired output is known and compare the output generated with the expected output. By reviewing how far from the expected value the output is, we can then step backwards through the layers, adjusting the weightings so that the new output is closer to the expected one. By repeating this process many times with different inputs, the weightings will eventually converge to produce the expected values for the given inputs, as well as hopefully for any new inputs. Okay, now that you understand the basics of neural networks, let's get started using them in R.